All right, you guys. So, welcome to absolute value word problems. All right. Now, what's important to know about these is that I know for some of you, you might be just able to read the problem and go, well, I know exactly how to figure that out. And I don't need to write an equation to solve it. Part of what we've got to do now is that the EOC has started to reword the questions to where the question actually says, here's your problem. But then in the next statement, it says, what equation or what inequality would you create in order to solve this problem? So we got to learn how to build those equations based on what they've given us here. All right, so it says here, we're just going to jump right in. It says the ideal diameter of a piston for one type of car is 100 millimeters. The actual diameter can vary from the ideal diameter by at most 0.007 millimeters. Find the range of acceptable diameters for the piston. Okay. All right. So big clue here is that we are looking at absolute value. Okay. The question is how do we write the equation? All right. Now I'm not a big fan of writing in pen because it doesn't allow me to erase as well as I'd like to, but my pencil's not as visible on this piece of paper that I'd like. All right, so we know that a diameter that is ideal is 100 millimeters. So when we manufacture it, that means we might be off, okay, in some ways. So I'm going to say that X, okay, is just a diameter. So X is just any diameter, okay? And we know that this diameter might be smaller or larger than this 100 millimeters because that's how it would be off. It might be smaller than 100 millimeters. It might be larger than 100 millimeters. Okay, so we need to figure out what that excess is. What is that leftover diameter? And we need to find out if it's in this acceptable range right here of being at most 0.007 millimeters. All right, so I'm going to take the diameter that I'm given and I'm going to subtract the ideal diameter. Okay. All right. And what I want that to do is I always want that to be, okay, I want it to be positive. The reason I want it to be positive is because I'm dealing with a measurement, okay? And these measurements, nothing here is going to measure negative, okay? So I want to, whatever I put in here, I want to be looking at the positive value of it, okay? And then it says the actual diameter can vary from the ideal diameter. So I took the actual and I subtracted the ideal by at most, okay, less than or equal to 0.007. Okay, so that's saying at most. Okay, that means you can be this measurement, okay, or less. If it's 0.008, okay, we've gone over the acceptable limit. So we have the absolute value of x minus 100. We want to know if that's less than or equal to 0.007. And if it is, then it's within our acceptable range of diameters. Okay, well, we talked about this, solving this right here. We talked about solving that on the calculator. All right, now this is where, okay, calculator is not always the best, okay, and solving something by hand might actually turn out to be quicker. So if I look here, I look at my picture, I got nothing going on here, okay, and I actually made sure I solved this problem before I turned the video on, okay. And I was like, okay, maybe I typed something in. And I didn't, but it was just a matter of finding it. But I knew how to find it. Okay. We know that this is a very small value and that it's going to hang around 100 because that's the ideal diameter. Okay. I'm nowhere near 100 on this part. So I'm going to zoom out. All right. So there it is. There's 100. I'm going to bring that over to the center. You could see something flicked. You could see that blue. There it is. See that blue? All right, now I'm going to zoom in. Okay, and it's going to take a lot of zooming. And this is one of those things. If you want to use that calculator, okay, Here's where it's going to get a little bit not fun. Okay. All right. So it's going to be a little bit difficult to get the whole picture here on my screen. Okay, but you can see right here, see how it crosses at 100.007. All right, let me zoom out a little bit. All right, and then we've got this one here. Okay, and this is good. So right in the middle, so that's 4, that's 2, so this is going to be 3. So 99.993 is right here. Okay, all right, so now I'm going to take what I learned yesterday, okay, and I'm going to write my interval, or in this case, I'm going to write that inequality that gives me that range. All right, so my final answer is 99.993 less than or equal to x less than or equal to 100.007. Okay, so there's my range. Okay, that is acceptable diameters for the piston. So if I were to pull one off of the manufacturing belt and measured it by hand, and it fell between these two measurements, okay, so if I'm looking here on this side on my graph, if I'm anywhere between here, so 99.3, 99.993, 994, 995, 996 to 100, and then a little bit over 100. Okay, as long as my piston fell into this measurement, okay, it would be considered acceptable and could be shipped off to the store. Okay, all right, number 2. The ideal weight of one type of model airplane engine is 32.85 ounces. The actual weight may vary from the ideal by at most 0.25 ounce. Find the range of acceptable weights for this engine. All right, so now some of you are thinking, well, it's the same problem. It is, okay? It's just different numbers, but it's almost worded the exact same way. Okay, we've got this ideal weight, but the actual weight can vary. So I'm going to let x be the actual weight. Okay, so the actual weight minus the ideal weight. We want to keep that measurement positive. Can be at most, it can be off, in other words, by at most 0.025. Okay, all right, so now if I go back here to Desmos, so part of what we're doing too is learning how to troubleshoot Desmos in case we can't see it. All right, so x minus 32.85 absolute value less than or equal to 0.25. Okay. All right, now I'm going to click the home button. That's going to send me back to the origin. All right, so again, not seeing my picture. And if I zoom out, oh, there you go. That actually did better than the last one. Okay, so now let's hide this. That's what those double arrows are. It'll hide it for the moment. Okay, let's zoom back in. Okay, this is one of the reasons I do like Desmos. Okay, all right. So now we have, okay, look, I just scrolled in one more time. All right, so 32.6 to 33.1. That is my acceptable weight ranges for this model engine. Okay, so now I'm going to write that as an inequality. So 32.6 less than or equal to x less than or equal to 33.1. Okay, all right, number 3. All right. Pretend that you're allowed to go within 8 miles per hour of the speed limit of 70 miles per hour without getting a ticket. Without getting a tick. That's pretty good. A ticket. Write an absolute value inequality that models this situation, then write an inequality that shows the speed you're allowed to go without getting a ticket. Okay. All right. Most of you probably could tell me it's 62 to 85 or 62 to 78. Okay. You know that if you're within 8 miles of the speed limit, under or over, in this situation, I don't hear of anyone getting tickets for going too slow. But if you're allowed to be within 8 miles of the speed limit, that's 62 to 78. Okay. So how do I write that? That's what we're trying to do. That's what we're trying to accomplish is how do I write that? Okay, so I'm going to let x be my actual speed. All right, so I'm going to take the absolute value of my actual speed minus 70, because that's the ideal speed. Okay, and as long as I am within 8, so less than or equal to 8. Okay, all right, so now I'm just going to go back here. Let's verify what I pretty much could figure out on my own. Okay, so x minus 70 less than or equal to 8. And now we're going to switch here, home. We're going to scroll out. There we go. And we're going to scroll back in. Let's hide this so we can get these numbers to pop up. There you go, 62 to 78. So 62 less than or equal to x less than or equal to 78. All right, so basically what we're saying is that the cop puts the radar gun on you and you come up between 62 and 78 on whichever road, okay, says that you've got to be going 70 miles, okay, per hour, or else you're getting a ticket. If he radars you and you are anywhere between 62 and 78, he's not going to come after you, okay? All right, so I'm going to do one more, and then you will have your own separate worksheet. They're not exactly the same. I've changed the numbers, okay? But you'll have your own separate worksheet to work through the problems. And if you need help, just let me know, okay? All right, in a poll of 100 people, Misty's approval rating as a dog is 88% with a 4.25% of error. Write an absolute value inequality that models this situation. Solve the inequality, okay? So we're going to take Misty's actual, okay, her approval rating has this margin of error, okay, so we've got to figure out what that margin of error is, okay, so we got to get that range. So we're going to take x, okay, will be her actual approval rating. We're going to subtract the 88, okay, and let's be good mathematicians and we'll say 0.88. Okay, we'll convert it to a decimal and then 0.0425. Okay, I wasn't even thinking about that. All right, so because we need to have it in decimal form. So 88% is 0.88 with a error, okay, less than or equal to 0.0425. Okay, all right, go over here. Let's type that in. So absolute value of x minus 0.88. So we put that decimal in because, yeah, we wouldn't be able to type in 88% into Desmos. Less than or equal to 0.0425. All right, and we're going to click home. Oh, there it is. All right, so we're going to scroll in. Okay, so let's go over here. All right, let's see if we can scroll in and get that number to pop up. There we go. So 0.8875 Oops, I didn't read that right. 0.8375. So 0.8375 less than or equal to x less than or equal to, okay, and then we're going to drag this over until we get to the other side. Oops. I'll fix my screen in a minute. Good Lord. This is why Desmos is not always the best in the world. All right, we should be getting close. I'm going to scroll back out. There we go. All right. 0.9225. All right, let me fix my screen so you can see what I wrote down. There we go. Okay. All right, so that is the inequality that models this situation. Okay. This is her approval rating with her margin of error. Okay. So this would be her confidence interval. Okay. So think about that in terms of percentages. So it'd be 83.75% to 92.25 to, because I can't erase, for percent. That's the confidence interval, okay? So we're able to take something that we learned in statistics and we've applied it here, okay? All right, so in order to keep the video not too much longer, because it's probably already gone long already, okay? You've got 10 problems that you're going to solve, okay? If you've got any questions while you're working on it, just send me a text and say, hey, Miss Barfield, I need some help on number 6, or I need some help on number 7, okay? And I'll be glad to help you, okay? All right, good luck, you guys.